All right. So one of the questions you asked us is why you need to change the opcode to 1011 and 0100. What it does and why not just maintain the opcode at 100 until the end. So before we can explain that, we'll just explain what does our opcode do. So the opcode I use is 100, 1011, and 0100. So we'll go through them. So 100 is write OPA in R4, OPB in R2, and performs OR and store results in register in R4, and RAM data address 100. Then afterwards, we use 1011 is because we'll take the data in the RAM address 100 and store into register 0. And then we move on to 0100 is because it will take the data inside R0 and use it to do OR with OPC. And then the result will be stored into RAM data address 100. So the reason why we have multiple opcode is one is because we want our CPU to be multifunctional. So you can mix and match the codes to perform whatever operation you want. You can do and or subtraction and or there's so many combinations you can do with it. And also we have this codes just because to illustrate that certain function is happening, right? So we can see from our CPU here that it can take store the address into the RAM, and it can also take data from the RAM and store inside the register. So for instance, this is our CPU. I will do this one more time. Right? So we can see here it's we'll start with opcode 1000. Our op A will be 0001, and our op B will be 01000, and our op C will be 0110. So at first here, we're just gonna do the 100 opcode operation. So as you can see here, when 0001 and 100 ORs will get 1001, which is 9, and the value is stored inside RAM address 4, 01000, as we can show here. Since the RAM data is saved here, so we move on to 1011. So we can see here the RAM data here. Now our CPU takes the data in RAM address 1000, and it will store inside register 0. So to prove that the register 0 has been saved later will be demonstrated by Yap, because that was his question. All right. So 1000. So now we'll move on to 0100. This is our final question. So you can see here when our 11001 or 0110, it becomes 9. Maybe it becomes F, because it'll become 1111. As you can see here, it's stored inside RAM data address 1000. So that's what we were trying to show you. This is how our CPU works lah. So then now for the next question, I'll pass it on to Yap.
So for my questions is, in which register does the value of op A, op B, and op C being stored? So I will show these values updated in the register file in real time. Going to demonstrate the opcode 0111, which is an operation between R7 and R1. The op A we insert will be stored into R7, and the op B we insert will be stored into R1. So the value I insert for op A is 2, and the value I insert for op B is 8. You can see in the register file, the R7 now now is having the value of 2, and R1 is having the value of A. You can see the result is stored into R7, and the result is also stored into RAM address 111. And then the next opcode is I'm going to show is 1100. So this opcode takes the values from RAM data address 111 and store it inside register 0. Zero. You can see in the register file, the R0 now having the values of 2. And then the last opcode I'm going to show is 0011. This opcode do an operation between R0 and OPC, and the result is stored into RAM address 111. So for example, I put 0100. I think the result will be 0. Yes. As you can see, the value in RAM data address 111 has become 0. The result will not be stored inside register file because the read and write register is set to 0, so it does not store inside register. And that's all for me.